Hey guys, welcome back. Before we move on to today's lesson, I just want to recap a little bit from yesterday. So yesterday we talked about how to name points and what they looked like. We talked about how to name a line. So you can name a line with two letters in any order, and those letters are just points that are on the line. We talked about how to name a segment. A segment, again, you can use two letters in any order. We talked about rays. Now rays were a little different. You still needed two letters, but order mattered for a ray. Like you had to start with the end point and go toward the arrow. We talked about naming planes. So planes, you need 3 points to name a plane, and it can be in any order, or the big capital letter that's by itself in a corner with no points around it. And we talked about the words collinear and coplanar. So collinear just means points that are on the same line. And coplanar are points or lines that are on the same plane. So collinear is same line, coplanar is same plane. Other than that, I think we just touched on some intersections. So we talked about the fact that two lines intersect at a point and two planes intersect in a line. So that pretty much sums up the lesson from 1-1, yesterday's lesson. So today we're going to jump into the next section, which is section 1-2. And this section is all about segments. So the first thing I want you to remember is what a segment is. So a segment is just part of a line, and it has two endpoints. So it has a starting point and an ending point. I also want you to know that a segment can be measured, which is what we're going to talk about a lot more today. And we can name it with those 2 points, the starting point and the end point, and it can be in any order. So in this particular segment, we know we can call this segment AB, or we can call this segment BA. So let's jump into figuring out how we find measurements of segments. So there's 3 basic ways that you can measure a segment. You can measure it on a number line, which is going to be like example 1. We can measure it using a ruler, or we can measure it algebraically. Now we're going to concentrate on the first one and the last one. So we're going to talk about the number line measurements, and we're going to talk about algebraically, but we're really not going to talk about the ruler side of things. So if I look at example 1, this is measuring from a number line, and it says use the diagram below to find the measures of RS, RT, and QT. So if I look at RS, all right, so RS is just from here to here. So we just want to know how far is it from point R to point S. So we can do this 2 ways. We can just count. So on the number line, if I move from R to S, we move over 1 spot. So the length is 1 unit. We could have also done 5 minus 4. So if you take one endpoint minus the other endpoint, that also tells you what your distance is or what your length is. Now I do want to point out, notice that the letters are italicized. So when you see the letters italicized and it's referring to a segment, that just means it wants the length of that segment. So look at RT, again italicized, it wants the length of R to T. So we're going to go from R all the way to T. So we can count it. So if I start at R, I'm going to go 1, 2, 3, 4 over. So this is 4 units. Or I could have said 8 minus 4, because T is at 8 and R is at 4, so 8 minus 4 still gives me 4 units. Now from Q to T, it's a little bit bigger, right? So a little bit bigger measurement here. Again, we can still count. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 units. Or I could have said, well, if T is at 8 and Q is at -2, if I have 2 negatives, it becomes a positive. So 8 plus 2 becomes 10 units. So again, we can either count it on the number line or we can subtract the 2 numbers. Either way, you figure out what the length or the distance is between those 2 points. Now, example 2 is more like a real world problem. And I pulled these numbers from Google Maps. So from Martinsville to Mooresville, it takes us 16.25 miles. And from Mooresville to Indianapolis, it takes 16.6 miles. So how could we find the distance from Martinsville to Indianapolis? Hopefully, when you added those together, you were able to get 32.85 miles. So we just took 16.25 plus 16.6, we added them together, and we were able to get 32.85 miles. Example 3 is a little bit different. It says a car with a trailer has a total length of 27 feet. If the trailer has a total length of 13 feet, how long is the car? So on this one, it's telling us the total length, and then it's giving us the length of the trailer. So I'm not going to add this time because I'm not putting the two pieces together. This time we're going to have to subtract. So if I take 27 minus 13, I should get the length of the car. And as you probably put in your answer, you should have gotten the answer of 14 feet. All right, now let's look at example 4. So it says in the diagram of collinear points, so we know collinear means they're on the same line. It says DE is 2, EF is 3, DE and FG are the same number. Find the length of each piece. So geometry is very visual, and that's what you're going to find as we go through these lessons. So the first thing I'm going to do, so on your paper, you can draw this segment, and I want you to label DE is 2. I want you to label that EF is 3. And then it tells us that DE and FG are the same number. So we know DE is 2, so that means that FG must also be 2. Now that we've written all of the information into our picture, we should be able to find the length of the 4 pieces that it asks us to find. All right, so we already knew that FG was 2. For DF, we have to go from D to F, so we have to do the 2 plus the 3, which is 5. DG is going to go from one end all the way to the other, so 2 plus 3 plus 2 is 7. And EG is just going to go from 3 to 2, so 3 plus 2 is 5. So that's how you would have gotten those 4 pieces, and hopefully you got those on your paper. Okay, for example 5, again, it gives us some information to start with. So the first thing we're going to do is we're going to draw this segment on our paper, and we're going to label it. So we've got HK, so from H all the way up here to K is 9. HI and JK are the same number, and it says that IJ is 1. All right, well, I obviously know this 1 is taken. So if I take 9 minus 1, then I know that we have 8 left over, and I know that the 2 pieces have to be the same number. So if I take 8 divided by 2, we should get that both pieces are 4. Now I can find the answers to the 4 pieces that are left. So from H to I, we know that's 4. That's what we just found out. From J to K, we know that's also 4. From H to I, so that's going to be 4 plus 1, which is 5. And from I to K, so that's going to be 1 plus 4, which is 5. All right. So basically, you're still kind of using a number line, a little bit more complicated, a little bit more complex, but still just looking at a line with some pieces on it. Now, example 6, now we're going to introduce some variables. So this one's going to be more algebraic. So it says if F is between E and G, and we know that EG, we know that the whole thing is 59, we want to be able to find the 2 pieces. Well, we know that if we took this piece, EF, plus this piece, FG, we should get the really big segment, the whole thing. So I'm just going to write that down. So we know that EF, which is 8x minus 14, plus the FG, which is 4x plus 1, should give us the whole thing, the EG part, which is 59. So if I take this little piece plus this little piece, we should get the whole segment. Well, this is what we talked about in the very beginning of class. So we're going to combine our like terms. So we know that 8x and 4x are on the same side of the equal sign, so we're just going to combine them. So 8 plus 4 is 12x. And then we have negative 14 plus 1, again on the same side of the equal sign. So negative 14 plus 1 is negative 13, and that has to equal 59. We're going to add our 13 to both sides. So that gives me 12x equals 72. And then we're going to divide by 12. So we're going to end up with x equals 6. So are we finished with this problem? I hope you said no, because it asked us to actually find the 2 pieces. So EF, which we know is 8x minus 14, so this is EF. We're going to put this 6 in, or substitute this 6 in for this x. So we're going to have 8 times our 6 minus 14. So 8 times 6 is 48. And then we're going to subtract our 14. So you should get that EF is 34. So there's our first answer. Now we're going to find FG. So FG is 4x plus 1. Again, we're going to substitute that x in for, or 6 in for that x. So that gives you 4 times 6 plus 1. So 24 plus 1 tells you that FG is 25. Now if I did it right and I add those numbers, we should get 59. So 34 plus 25 does give us 59, so we know that we've done this problem correctly. Okay, the final thing we need to talk about, there's 2 more vocabulary words. The first word here is congruent segments. So these are just segments that have the same measure or the same length. So segments that have the same measure or length. Now, there's an abbreviation for congruent. It's basically a squiggly with an equal sign. That's the easiest way to remember it. And I can mark it in the picture with these little dash marks. So if you look here, I have a dash mark here and a dash mark here. That means those are congruent. I showed you in a picture of a triangle as well. So that just tells you they're congruent. They're the same. They're equal is kind of how you think about congruent. And the last word is midpoint. So midpoint is just a point that cuts a segment into 2 congruent segments. In other words, it cuts the segment in half. It makes the 2 pieces equal. It makes them exactly the same. And notice in the picture, like it put the little dashes showing you that it was equal. So from A to the midpoint is the same as from the midpoint to B. So if I look at example 7, that one's going to use that concept. So it tells you that C is a midpoint. It tells us that BC, this piece here, is T plus 1, and it tells us that CE is 15 minus T. Now, since it told you C was the midpoint, we know that this piece and this piece are the same. They're equal. So I'm going to set them up to where they are equal to each other. So now I just have to solve for T. So I'm going to add a T to both sides because this was negative. So we're going to add it to make it go away. So we get 2T plus 1 equals 15. Then I'm going to subtract that 1 from both sides. And then I'm going to divide by 2. So we get T equals 7. Now, if I look back up there, it says, what is BE? So we don't get to stop here. We have what T is, but we have to plug this back in, substitute it back in to figure out what the lengths are. So we know that BC is T plus 1. So that's going to be 7 plus 1, which means BC is 8. We know that CE is 15 minus T. So in this case, it's going to be 15 minus 7. So we get CE is 8. And if I want the whole thing, if I want BE, so from the start to the finish, we know that we just add the pieces together. That's what we've been learning about in this section. So if I take 8 plus 8, notice they should match, I get 16. And it doesn't tell me any units, so we're just going to say 16U. So that would be my final answer for this particular problem. And I think that pretty much sums up segments. So we talked about what a segment is, how to name it again. We've talked about how to find the length or the measure of a segment on a number line. We talked about how to find it algebraically. And then we introduced this concept of congruent, which is just the same length or the same measure. Or you could think of congruent means equal. And midpoint is just a point that divides a segment into 2 congruent pieces or 2 equal pieces. So in other words, a midpoint cuts it in half. And then we saw an example of how we use midpoint to solve a problem algebraically to find out what the length of that segment is. So I think that pretty much sums everything up. And if you guys have any problems, please reach out. Thanks.